Here's the third problem. So I've written it in brief here. We have px given, we have qx given. These are two polynomials with real coefficients. B, C and D are unknowns, and we also have px into qx equals to q times px. So basically this is also a problem which is a composite function. This is a composite function of polynomials. We need to find the actual question is we need to find all the real roots of p of qx equals to 0. So we need to find the roots of this equation p of qx equals to 0, and we are given this all these informations. To do this, firstly we consider this given information, which is the most vital one for us. Px into qx equals to q times px. Since there is such x dashed, if we take such x dashed such that p of x dashed is 0, we can take such x dashed because x is ranging over all the real numbers. So if we put x dashed in this one, because this is an identity, because it is written that it is valid for all real x, so that will give us p of x dashed into q of x dashed is equal to q times p of x dashed. Now we have px dashed equal to 0, as I've said, because x dash is a root, so this will turn 0 and this will also turn 0. So we have q0 equals to 0. From here you can see q0 is equals to d. That means we have d equals to 0. Okay, so we have qd equals to 0. Now we need to find the other coefficients too. Again, come back to this relation, px times qx equals to q of px. If we just put in the values now, okay, px times qx equals to, you can see q of px will be, just put in px here, it will be px whole square plus c times px, and d will be 0, so there is no d actually, plus c times px. Okay, now you can see px gets cancelled from both sides, and it's cool to cancel all these px's because they are not 0. So be sure that it's an identity, so there is no point of non-cancelling of this thing. So we can cancel px from both sides to get an expression. So we have qx, which is, let us put that the value x square plus cx, and d is 0, so remember this is actually x square plus cx. Okay, we have x square plus cx equals to, there is px left, so px is x square plus x by 2 plus b plus c. So these are the two equations. We can cancel x square from both sides, and we will be left with an identity. Since this is an identity, so it holds for all values of x, and that's why we can say that the corresponding coefficients must be equal. This can be treated as a vector in a three-dimensional space, so we won't be talking about that. So in this way we can say c will be half, because the coefficients of x must be matching and the constant terms must be equal, that is b plus c must be 0, that is c will be minus c will be half, so b will be minus c, that is minus half. So we have the three coefficients. Let's just write here, d is 0, okay, b is minus half, and c is half. So this is the half of the problem. We have found the coefficient successfully. It is b minus half, d 0 and c half. So let us rewrite the polynomials. It is px equals to x square plus x by 2, b is minus half, so it is minus half. Let us find the roots. So if we equate it to 0, we will see x square, if we multiply by 2, we will get 2x square plus 2x minus 1 equals to 0. This means 2x times x plus 1 minus of x plus 1 equals to 0. This will give you two roots, x will be half and minus 1. Okay, so we can consider that p of half equals to p of minus 1 equals to 0. Remember the question, we are to find the roots of this one, p of qx equals to 0. Okay, but we have already found that there are only two numbers in this universe in the real category that will let p of x will be 0, and that is half and minus 1. So qx must be either half or minus 1, and it cannot be, if it is not them, so there is no such qx, so it must be half or minus 1. So let us equate them one by one. if we equate qx equals to half, okay, qx is this one, so x square c is half plus x by 2 equals to half. Okay, let us multiply by 2 on both sides and we will get 2x square plus x minus 1 equals to 0. If we solve this, this is the same exact equation like this, and it will give you x equals to half and minus 1. If we take the minus 1 case, qx equals to minus 1, it will give us x square plus x by 2 equals to minus 1. Multiplying by 2 will give you 2x square plus x plus 2 equals to 0. But note that the discriminant will be 1 minus 8. Not 8 actually, 1 minus 16, that is minus 15, which is less than 0. So the roots will be all imaginary, and that's why we cannot take this into consideration. So we have to find only real roots, and we have got the real roots as half and minus 1. So these are the only answers to this problem. So this is, we have completed the third problem.